starting. Alright, algebras, here's the key for synthetic division. Pay attention to the patterns. It's lots of fun once you get used to how to go ahead and what the coefficients and numbers represent. When I'm dividing this trinomial by this binomial, I want to go ahead and list the coefficients. A 1, a 3, and a -6. Remember, synthetic division is a shortcut to long division. If I want to know what I'm testing, I'm seeing if x can be equal to -1. So this number out here represents the solution, not the factor. Alright, so step 1 is to go ahead and bring down your first coefficient. Our next step is to multiply -1 times 1, and that gives me -1. When I combine those terms, I get +2. -1 times 2 is -2. When I combine those terms, I get -8. Which means that this does not go in evenly because this is my remainder. So when I list my quotient, I'm going to go ahead and recognize that here is my constant and here is my x. So it's going to be x plus 2 plus my remainder of 8 over my original factor of x plus 1. Alright, next step. I'm going to list my coefficients of 1, -1, -1, and +2. I want to check my exponents, cubes, squares, linears, and constants, which is x to the 0. I'm going to go ahead and draw my synthetic box, and I'm going to recognize I'm testing to see if 2 is the solution. 1 comes down. 2 times 1 is 2. Combined terms is 1. 2 times 1 is 2. Combined terms is +1. And 2 times 1 is 2, giving me a remainder of 4. Here's my constant, here's my x term, and here's my x squared. So my quotient is x squared plus x plus 1 plus a remainder of 4 over x minus 2, which is what my divisor was. So that's 1. 2 times 1 is 2. +1, 2, +1, 2 with a remainder of 4. Alright, next up for number 3. I'm going to see if x plus 3 divides evenly into x squared plus 5x plus 2. Here's my synthetic box. Coefficients of 1 and 5 and 2. And I'm testing to see if -3 is a solution. 1 comes down. -3. +2. -6. -4. So no, it doesn't go in evenly, and it has a remainder of -4. Here's my constant, and here's my x term. So my quotient is x plus 2 plus -4 over my divisor of x plus 3. Alright, we're not having much luck. Let's see if 5 is a solution to 1, -3, and -5. 1 comes down. 5, +2, 10, and a remainder of 5. That's 1x plus 2 plus 5 over my divisor. Alright, now pay attention here. We have some issues here with this next polynomial. First of all, it's out of order, and I'm missing a squared term. So I have to rewrite this as x plus 4 plus 2x cubed plus 0x squared minus 3x minus 6. We need to make sure we have this placeholder, and we need to make sure that my powers go 4, 3, 2, 1, none. So I'll draw my synthetic box. Coefficient of 1, 2, 0, negative 3, and negative 6. I'm testing to see if 2 is a solution. 1 comes down. 2 times 1 is 2. 2 times 4 is 8. 2 times 8 is 16. And 2 times 13 is 26, with 20 left over. When I go to write my quotient, constant, x to the first, x to the second, and x to the third. Note my quotient is 1 less power than my dividend. X to the third plus 4x squared plus 8x plus 13 plus 20 over my divisor, which is x minus 2. Alright. When I look at this one, I have 2 and 1 and my constant. So I'll rewrite this trinomial in descending power. So when I draw my synthetic box, my coefficients of 2 and 1 and negative 3 are accurate. I have a solution of x is equal to 1 that I'm testing. So my 1 goes here. 2 comes down. 1 times 2 is 2. 1 times 3 is 3. And there, finally, we have a 0, which means that x minus 1 is a factor. So that means that x is equal to 1 is a solution. So when I rewrite my 2x plus 3 as a quotient, there's no remainder because that went in evenly. Alright, let's check out the back. Now we can use synthetic division to evaluate. If I have an x value of 2 as an input, if I wanted to, I could say that f of 2 is equal to 2 squared plus 2 minus 3, or I could use synthetic division. I could use 2 and see what the outcome is of 1, 1, and negative 3, which are my coefficients for my squared, my linear, and my constant term. 1 comes down. 1 times 2 is 2. 3 comes down. 2 times 3 is 6. When I add them together, I get 3 is the remainder. Therefore, f of 2 has a value of 3. I can prove that because I have 4 plus 2 minus 3, 6 minus 3, f of 2 is equal to 3. Alright, what is g of x when x is equal to 3? So use synthetic substitution. So 3 is going to go in my synthetic box, and I have a 1, a 2, and a 6. 1, 3, 5, 15, 21. There's my remaining value. Therefore, g of 3 is equal to 21. Again, if I wanted to test it, I could ask myself, 3 squared plus 2 times 3 plus 6, 9 plus 6 plus 6, 15 plus 6, 21. Alright, determine if the following are factors. Why not? Or why? Show synthetic division to support your answers. So I want to check and make sure, I'm missing my x squared. Don't forget about that. That means I have 0 of them when they're not there. So if I have 2 and negative 1, 0, 2 and negative 1 as factors, or as coefficients, I draw my synthetic box, and I'm checking to see about negative 1. 2 comes down. Yep, that is a factor. X plus 1 goes in evenly because when I bring my 2 down, negative 2, negative 3, positive 3, 3, negative 3, negative 1, and then it works out. So yes, this one is a factor. Alright, let's try our next one. Let's try this one. I have x is equal to 1. So now I'll test 1 with those same coefficients. 2, negative 1, 0, 2, and negative 1. Here's 2, 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 3 is 3. And I wind up with a remainder of 2. Therefore, no, it's not a factor. Alright, let's check out x plus 3. X is equal to negative 3, so I'm testing to see if negative 3 is a solution. So I have 2, negative 1, 0, 2, and negative 1. 2 comes down. Oh dear, this one's getting into high numbers fairly quickly. Negative 3 times 21 is negative 63. This makes negative 61. Negative 3 times negative 61 is going to be positive 183. So I get a value of 182, therefore no. Only this one worked because this one has a 0 remainder. Alright, which of the given numbers are zeros? Show synthetic work to support your answers. You try this on your own and come back and check. Alright, guess what? We're 0 for 3. None of these worked out to be 0, so therefore it's no. Hey, I want to go back and talk about number 2. In case you were thinking you're going to get a Smartie, I missed this negative. Therefore, this works out to be 0. Therefore, there's no remainder. All right, we'll see you in class.